Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous lecture we have talked about the different kind of chemical as well as the physical properties of boron, as well as we have also discussed about the different uses of boron. And now based on that we are going to talk about the different compounds that consist of boron. So that's the reason we are going to talk about the methods of preparation, we are talking about the chemical properties as well as the uses of those compounds which consist of boron in them. So based on that, let us start with this. So in this topic, we are going to talk about the important compounds of boron, and those are basically borax, orthoboric acid, and diborane. So in this, basically, we are going to talk about what are the different methods of preparation of this compounds, as well as what are the different properties that could be exhibited by these compounds, as well as the uses. So let us talk about the first one, that is borax. So borax is the one which has a molecular formula of that is Na2B4O7, and sometimes it is formed in a crystalline, that is in a hydrated form also. So that's the reason. 10 moles of H2 is also been associated with that, and that is known as borax, and it has also applications that we are going to talk about. And talking about the next one, that is orthoboric acid. So boric acid, basically we are talking about orthoboric acid, that is H3BO3. So even we are going to talk about this one, and ultimately we are going to talk about that is diborane, that is B2H6. So since we are going to talk about each of it one by one, so let us start with the first one, that is what is borax, and basically what are the different methods to prepare it, and what are the different properties that could be exhibited by borax. So now let us start with that. So talking about the preparation of borax, so we see borax can be obtained from the mineral basically known as colaminate, and that's the reason that what we have to do is we have to treat it with that is Na2CO3, that is sodium carbonate. So in this case, basically that mineral which consists of calcium as well as the boron as a main component, and so in that case, basically the reaction will turn into in such a way that is we could obtain that is Na2B4O7, that is nothing but borax, along with that of that is NaBO2, along with that of that is CaCO3 that will be precipitate out, and this is also we can obtain CaCO3. But the main component in this reaction is basically borax, and that is what we will obtain over here. And so that's this is one of the method where we could that is prepare borax. But borax is also present naturally, and that's the reason that it could be obtained in a through nature, or as well as we could obtain it from this kind of mineral, that is colaminate, and that is the thing that we have talked about in the preparation. So now let us talk about the next one, that is the property of that is borax. So the properties of the borax are as follows. So now let us talk about the different properties of that are exhibited by boron. So let us talk about the first one, that is what happens when boron is treated with water. So that is basically the hydrolysis of borax. So basically the hydrolysis of borax gives an alkaline solution, and that is what the reaction is being represented over here, and that is what we are going to talk about, that is borax, that is basically Na2B4O7 whenever it is been treated with water, and in this case basically we are reacting with that is 7 moles of H2. So the product that we could obtain over here is basically 2 moles of NaOH, and along with that of that is H3BO3, that is known as orthoboric acid. So here somewhere we have also obtained that is orthoboric acid, and this is what we are going to also talk about in the further topic. So in this case, basically the solution that it turns, it is basically basic in nature. The reason behind that is the NaOH that is been obtained, actually it is a very strong electrolyte, as well as we could also say that it is a very strong base. That's the reason that the solution that we could obtain, there will be more concentration of OH minus ions, and that's the reason that the whole solution will be basically, it will be basic in nature. And talking about that is orthoboric acid, even though it is a twin acid, but it is a very weak acid, and that's the reason that it won't dissociate, and that's the reason that the solution will become basically it will be more alkaline, and that's the reason that we are talking about the first property, that is hydrolysis of borax will give such kind of a base. So this was something related to the hydrolysis, and now let us move on to the next one, that is what will happen if borax undergoes a different reaction. So as we know that borax is the one which consists of that is water molecules also associated with it. So that's the reason it can undergo that is a dehydration process, and that is what we are going to talk about. So let us understand that one. That is borax on heating, it loses water of crystallization. That is the 10 molecules of H2 that is associated with borax, and that undergoes that is dehydration, and the substance that we could obtain, that would be a white fluffy substance, and that is what we could obtain as a borax, which is basically now turned into anhydrous form. So on further heating, it melts to give a clear liquid which solidifies to transparent glossy bead that consists of basically sodium metaborate. So this is what I want to talk about. That is whenever that is the borax that has been obtained after the crystallization, after the dehydration process. So in that case, basically, even though if we further heat it, so during the further heating, that is the borax, it will melt, and during melting, obviously it will turn into liquid. And suppose if that liquid it again it's solidified, or we have solidified it, so therefore the substance that we could obtain is basically a transparent glossy bead, and that transparent glossy substance will consist of basically sodium metabolic. So now the reaction can be shown in this method, and that is, so this is the reaction where we have introduced, that is borax that undergoes, that is uh, dehydration process or removal of water. So in this case, basically Na2B4O7, which is associated with 10 moles of H2, it undergoes dehydration on heating, and that's the reason that we could obtain, that is 10 moles of H2. And the thing that we have obtained is basically a white fluffy substance, and that is basically Na2B4O7, which is nothing but a dehydrated borax. So if that white substance is again further heated, and it has been tried to, and we tried it to melt it, so that's the reason that we could get two substances, and those two substances are basically NaBO2, or basically we could name it as sodium metaborate, as well as B2O3, and this B2O3 is nothing but boric anhydride, and this is what we will obtain over here. So now this is the something basically it is known as borax bead, and that's the thing where we could say that that is very transparent glossy material. And now, so these two substances that have been obtained, they are basically used for borax test. And what are that? Let me talk about that one. So basically borax test is basically used for detecting the metal oxide, and that is what I am going to talk about. And for example, here I have mentioned over here. So in this case, basically, since we know that is on heating borax, we could obtain, that is B2O3, and basically known as boric anhydride. And that boric anhydride that has been produced, so what we have to do is we have to take a platinum wire, and on that, suppose if we have obtained, that is CO, and along with that of that is borax, if we try to mix it, and if we try to burn it, so in that case, because we know that B2O3 will be obtained, so in this case, basically the metal oxide, that is in this case, basically we have introduced, that is cobalt oxide, so that will react with that of the B2O3, and the product that we could get is basically COBO2 twice. So this is what we have will get, and basically this is the substance which is basically blue in color, and basically we could also say that it is a blue color bead. So during this test, we could also say that the borax, which consists of which obtains basically B2O3, that reacts with the metal oxide, and the blue color is been obtained. So this is kind of a borax test that we could use because of the on dehydration as well as on further heating. So this was the second property that I was talking about, and now let us move on to the next one. That is, so this is the one that I am talking about, and that is basically borax. They undergo reaction with that of the mineral acids, as well as it also undergoes reaction with alcohol. So this is what I am going to talk about. That is, when the borax is heated with, that is ethyl alcohol, along with that of that is concentrated H2SO4, then it gives a volatile vapor substance that is basically triethyl borate, and which burns with a green edge flame. So there also we could easily detect whether the boron is present or not, so as to detect whether boron is there or not. So that's the reason the boron, that is when we are talking about, that is borax especially. So borax is when treated with, that is H2SO4 along with that of the water molecule, so as to obtain, that is Na2SO4 along with that of, that is orthoboric acid, that is H3BO3. So this orthoboric acid is being treated with further it is being treated with, that is alcohol. So during this treatment, actually it forms a volatile vapor substance, and that is nothing but triethyl borate, and along with that of, that is 3 moles of H2. But this volatile substance during burning of this, because we are burning this kind of reaction, and that's the reason that at the edge we could get a green color. So therefore we could easily detect whether that substance consists of boron or not. So this is what the different kind of chemical properties that I was talking about, and that's it. So these are the properties, as well as the preparation from which we could prepare borax, and talking about the last one, that is uses of borax. So we have earlier also talked about the uses of borax, but there are also some points that I want to talk about, and those are, So those uses are basically are as follows, as I have mentioned over here. That is, it is used in the manufacturing of optical as well as hard glasses. So that is what I have mentioned earlier also. That is, borons or the compounds which consist of boron, they are basically used in preparation of pyrex, and that is nothing but glass ones and all. So in this case, basically we use borax to make a hard glass and optical glasses also. As well as the next use that I'm going to talk about, that is borax is used as a flux for soldering and welding. So this is different thing that we have got to know. And the only thing that we have got to know, that is borax are being used to prepare, that is enamels as well as paints, and that are being used in the earthen pots so as to protect it, and so that there will be a formation of a layer that could resist the stain. So in this case, basically borax is also used as flux for soldering and welding. So this is the second point that I have talked about. But still, borax has various uses that we have studied earlier. That is, it is being used in preparation of enamels and paints, and that's the reason that it has been used in, that is, protecting the layer of the earthen pots so as to resist stains. As well as it is also used as an mild antiseptic. So these are the uses of the borax that we have talked about. So this was what I have completed. That is the first compound that consists of that is boron in this topic, and that is basically borax. And now let's move on to the second compound, and that is, so now let us talk about, that is orthoboric acid. So talking about orthoboric acid, let us understand the different methods to prepare the orthoboric acid, and this is what we are going to talk about. So starting with the first one, that is it can be prepared from borax. So this reaction we have did earlier only, that is whenever the borax was being treated with the H2SO4 and with that of the ethyl alcohol so as to form a, that was a test where we could determine whether the boron is present or not. So similarly, in that case, what we have used is we have used the sulfuric acid, but in this case we are going to use that is HCl. So in this case also we could obtain the orthoboric acid, and the reaction is as follows. That is the borax, that is Na2B4O7, is been treated with, that is 2 moles of HCl along with that of 5 moles of H2O so as to obtain, that is salt, that is 2 moles of NaCl, and along with that of, that is the desired product that we need, that is orthoboric acid, that is 4 moles of H3BO3. So this is the reaction that we have made to, so as to understand that how the orthoboric acid can be prepared. So that was the first one. But there are also various methods to prepare the orthoboric acid, and this one is as follows, where we have used, that is colimonite, and basically in this case basically we are using this kind of mineral, that is which consists of calcium as well as boron. In this manner, that is Ca2B6O11. Whenever it is been treated with that of, that is 4 moles of SO2, that is sulfur dioxide, along with that of the water molecule, then the product that we could obtain is basically calcium hydrogen sulfate, that is CaHSO3 twice, along with that of, that is orthoboric acid, that is 6 moles of H3BO3. So this is what we have, and this is how we can prepare orthoboric acid. So this was related to the preparation, and let us talk about the properties. So now let us understand the different properties that could be exhibited by, that is orthoboric acid. So starting with the first one, that is whenever the orthoboric acid is being treated with water, as we know that orthoboric is basically a weak acid and it is a white substance, white powder substance. So that weak acid, whenever it is being treated with water, so therefore the product that we could form is basically BOH 4 times, and that is nothing but a complex where we could find that is H plus. So here, why we could obtain, and we know that water is the one which is basically neutral in nature. So that's the reason whenever an acid, that is orthoboric acid, whenever it undergoes, that is hydrolysis, then the solution that we could obtain is basically acidic in nature, and that is basically the solution will turn into an acid in nature. So therefore, this was a process where we have also mentioned that the how basically orthoboric acid is basically in acidic nature, as well as what is the reaction when it undergoes hydrolysis process. So this is the thing that I was talking about, and now let us move on to the next one, that is what happens when the orthoboric acid undergoes decomposition reaction. So this is the reaction that I am going to talk about, and so there are different kind of properties that could be exhibited by the orthoboric acid. So talking about this reaction basically, so this orthoboric acid, whenever it undergoes decomposition, and that's the reason that water will be obtained. So that's the reason that H2 from this, along with that of one oxygen atom, that will be removed in the form of H2, and that is the thing that we could obtain, that is HBO twice. So this is nothing but that is metaboric acid. So this metaboric acid basically, when it undergoes further that is decomposition, then we could obtain, that is whenever 2 moles of metaboric acid, when they will undergo decomposition, then water molecule will be liberated. Along with that of, we could obtain, that is B2O3, and that is nothing but boric oxide. So this is how the second property that I was talking about. And but there are also different kind of property that could be exhibited by the orthoboric acid, and those are as follows. So in this, basically, we are going to talk about that since we know that orthoboric acid, whenever it can be reacted with that of a base, and that's when the salt will be produced. So similarly, in this reaction, basically, we are going to talk about whether how the reaction takes place, or how the kind of formation of salt takes place whenever the orthoboric acid, that is H3BO3, it reacts with a base like NaOH, which is a strong base. So this NaBO twice is nothing but known as sodium metaborate, and that is nothing but a salt. And talking about the next one, that is we could also obtain that is water as a byproduct. So this was the kind of a neutralization reaction or a formation of salt that consists of boron. And now let us move on to the next one, and this is the reaction that we will talk about. And this is the thing that we have did earlier only. That is whenever the borax was treated with that of the sulfuric acid, and so as to form that is say orthoboric acid, and that undergo reaction with that of the alcohol so as to obtain a volatile substance, and this is the reaction. Where the orthoboric acid, whenever treated with that is ethyl alcohol, it will form a volatile substance, and when on burning, it will form that is OC2H5 thrice, and that is basically known as triethyl borate, and that is a very volatile substance, and that's the reason that on burning it will form a green color, or it will form a green flame, and that is how we could detect whether the compound consists of boron or not. So this was something that was a reaction which was for the orthoboric acid. So this are the chemical preparations as well as the method of preparation as well as the properties where we have discussed about the orthoboric acid. So let me talk about the uses of it. So the uses of it is very simple, as we have discussed earlier also, that is it is basically used as a mild antiseptic, and that's the reason namely they are known as boric lotions. And the next one is basically we know that it has been used in as a food preservatives also, as well as it is also used in that is soldering, as well as it is also used in preparation of certain layers that could be used on that is earthen pots, basically known as enamels and paints, so that resist the stain on it. So this were the certain things about the orthoboric acid. And now let us move on to that is diborane. So here we are going to talk about that is diborane, and here we are also going to talk about that is what are the different methods to prepare diborane, as well as what are the different properties that could be exhibited by diborane. So let us talk about the first one, that is for preparation. So basically, diborane, which has a molecular formula of B2H6, can be obtained by that is by a reaction where we could find that is whenever BF3, that is boron trifluoride, whenever it's treated with that is lithium aluminum hydride. So therefore 4 moles of boron trifluoride, it's reacting with that is 3 moles of lithium aluminum hydride, so as to form that is 2 moles of diborane, that is B2H6, along with that of that is 3 moles of lithium fluoride, along with that of 3 moles of aluminum trifluoride. So this is one of the method where we could obtain that is a diborane by usage of that is boron trifluoride, along with that of the lithium aluminum hydride. So this was one of the method, and talking about the second method, that is what happens if the boron trifluoride is been treated with that is sodium hydride. So the second method that I'm going to talk about is what happens when the same, that is boron trifluoride, is been treated with that of that is sodium hydride. So in this case, basically, the 2 moles of boron trifluoride is treated with 6 moles of sodium hydride, and on heating, it produces that is 1 mole of diborane, that is B2H6, along with that of 6 moles of NaF. So this is kind of a substitution reaction that has taken place over here, and that is how we could obtain that is diborane. And talking about the next kind of preparation is that is whenever the sodium boron hydride is treated with that of the iodine. So the product that we could obtain is that is B2H6, along with that of 2 moles of Na, along with that of that is H2 gas. So this is how we could obtain that is diborane. So these are certain kind of chemical methods so as to prepare that is diborane. And now let us move on to the next one, that is properties that could be exhibited by diborane. So talking about the properties that are being exhibited by that is diborane are as follows. So the first property or the first chemical reaction I am going to talk about, where diborane is being treated with that of that is oxygen. So in this case, basically the diborane is treated with that of the oxygen, basically known as a combustion reaction, and in this case, basically the product that we could obtain is B2O3. So this B2O3 is basically known as boric oxide, and along with that of there will be release of that is 3 moles of H2. So this is a kind of reaction where we could get lots more of energy, as well as that boron is been traded with that of oxygen, and basically the water is been also obtained, as well as the irrespective oxygen is also obtained. So this was the first reaction that was related to the combustion reaction. So now let us move on to the next one, that is what happens if the diborane is treated with that of the H2, or basically this is kind of a hydrolysis process that takes place over here. And in this case, basically B2H6 is being treated with 6 moles of H2, so as to obtain that is 2 moles of BOH thrice, along with that of 6 moles of H2 gas. So in this case, basically this is the product that we could obtain. Basically it is basic in nature, or basically 3 moles of BOH thrice has been obtained over here, and that is what we have. And now let us move on to the next one, that is, so whenever we talk about that is B2H6, so basically whenever it is being reacted with that of that is a Lewis base, like that of the carbon monoxide, or that is tertiary ammonia, or tertiary amine. So in this case, basically we'll get a reaction that is B2H6 when reacts with that of a Lewis base, like 2 moles of CO. Then we could get an adduct. So that adduct is basically 2 moles of BH3.CO. So similarly, it could also react with that of a Lewis base, like trimethyl ammonia, and in this case, basically the product that we could obtain is basically 2 moles of BH3.NMe thrice. So this is what we have, and so this is what the reaction takes place. And now let us move to the next one, and that is what will happen if basically the diborane is being treated with that of a base like ammonia. So in this case, basically 3 moles of B2H6 basically diborane is being treated with that of 6 moles of NH3, so as to obtain a particular complex. And if that particular complex is basically treated with that of or it undergoes that is heating, and the product that we will obtain in this case is B3N3H6 plus 12 moles of H2. So it has been found that the product that we have obtained over here is basically known as, so product that we have obtained is basically known as borazole, and borazole is also known as inorganic benzene, and that's the reason that the product that we have obtained is basically borazole, and this is how the reaction takes place. And talking about the structure of borazole, it is very simple, and it is very resembling to that of that is benzene, and the structure will be represented as basically, since we consist of 3 boron atoms, so therefore this is the structure that I am talking about. So it is very much resembling to that of the organic compound, that is benzene. So that's it. So this is what the different kind of chemical properties of the diborane was, and so that's it. This is what I want to talk about. And talking about that is diborane. Let me talk about the structure of diborane very briefly. That is, it has been found that the structure of diborane is in this manner. And these are the 2 terminal that is hydrogen atoms, and here we could find the structure as this one. So this kind of hydrogen bonding that it creates basically a special kind of bonding that is known as a banana bond. Yes, we could also write the structure in this way, where basically 2 hydrogen bonds are basically attached to 2 hydrogen are basically attached to the boron, and this is how basically a kind of bend shape bond will be obtained, and this is the hydrogen that forms banana bond. So this is what I want to talk about in a brief manner. So that's it, friend. That is what I want to talk about. That is, these are basically the different compounds that consist of boron, as well as we have also understood that what are the different methods to prepare it, as well as what are the different properties that could be exhibited by this kind of compounds, as well as we have also discussed about the uses. So that's it. So this is what I want to talk about, and thank you friends for watching this video. I hope you have understood this video very clearly, and I hope you will share this video with your friends too. So till then, don't forget to subscribe Ekeeda channel. Thank you so much.